All right, let's talk about electric current. As soon as I get charge moving, we call it electric current. Okay? If it's not moving, we call it electrostatics. Okay? So if we look at this cross section of a wire, we've got electrons moving down the wire. The number of electrons that move past any point in the wire, like maybe this point right here, each second is called current. So we have current is equal to the amount of charge that moves by each second. And this is charge in coulombs, and that's a capital C. Time, and we want that as usual in physics in seconds, and this is current. We've run out of letters, so we use an I, and it is measured in amperes or amps, and it's a capital A. Before they understood many years ago what current was, they defined current as going from the positive terminal of a battery to the negative terminal. So if I draw my battery here, I'll just put that. If this is plus and this is minus, they had it going from the positive terminal to, oh, this is a negative sign. Let's do that. Can I get to it? No, this should be a negative sign here. Current goes in this direction. And then they realized what current actually was, and it's the flow of electrons, but electrons don't go away from something positive towards something negative. Electrons are negative. They don't want to head towards something negative. So it actually turned out that the electrons were flowing in this direction. So be careful what's being said to you. If we talk about which way is the current flowing, we're going positive to negative. Or if we talk about which way are the electrons flowing, we're going from negative to positive. Okay? There's two types of current named after the Australian rock band, AC/DC. Alternating current, it's the one that comes out of the wall. It goes back and forth in the wire. So the electrons are going this way, and then they slow down, and then they go the other way, and then they slow down, and then they go the other way, and they slow down, and they go back and forth. They don't actually get anywhere. It's a sine function. So if I plotted I versus t in seconds, it's gonna do this. It's going to go in one direction and then the other. And in physics, it's all planned out. They actually use sine functions to do calculations around current, alternating current, when they're designing things. So if you're rubber running, whenever you use sine, if you're an engineer, electrical engineer, you'll use it here. The other type is direct current. This is the one that comes from batteries. Here, the current only goes in one direction. It's pretty much a constant level over time. Okay, over time, as the battery starts to die, the amount of current will go down, but it'll be fairly constant for a long time. And we measure current using an ammeter. The symbol when we're drawing diagrams is like this. It's an ammeter. And we connect it in series. And series means we go from one thing to another thing to another thing. There's no branches in between these things. It's one, then the other, and then the other. So for example, here's the symbol for a battery. Here's the symbol for an ammeter. And here is a symbol for a resistor, which is some sort of load, something that's using up power in the circuit. The current will flow this way, so it's attached in series. So first it's the ammeter, and then it's the resistor. It's not the ammeter, and then I could go to the resistor, or I could go somewhere else. Let's another branch off of here. There's only one path. That's what series means. This is how I hook them up. And those of you who remember things about electricity, the other way to hook something up is in parallel, and we'll be talking about that in a minute. And that is our look at what electric current is. It's pretty straightforward.